Hey guys, welcome back to Cyber Platter. Today we'll discuss Linux interview question and answers. If you want to know about other topics, technical ones, I will link that in the description box. It is related to security, EDR, SIM, incident response. So I will link that in the description box. Let's start with the first question. What is the Linux kernel and how does it differ from Linux operating system? Linux kernel is the core component of the Linux operating system. It serves as the bridge between the hardware and software. It manages the hardware resources such as CPU, memory, storage, and peripheral devices and provides essential services to the higher level software components. It is a monolithic kernel, which means that it contains the core functionalities within a single large piece of software. The kernel is loaded into memory during the system boot process and remains in memory while the system is running. Now let's look at the Linux OS. The Linux OS consists of the Linux kernel along with various system libraries, utilities, and applications that provide a complete environment for user interaction and software execution. So, the operating system includes the shell, user interface components, system administration tools, and other software that allows users to interact with the system. The operating system also includes the file system hierarchy, which organizes and manages files and directories. So, in summary, the Linux kernel is the core component responsible for lower level hardware management and system resource allocation, while the Linux operating system is the combination of the kernel and higher level software components that provide a user friendly environment for running applications and performing tasks. The kernel is an integral part of the operating system, but it represents only one piece of the larger software ecosystem that makes up the complete Linux operating system. Let's go to the next question. Describe the basic directory structure in a typical Linux file system. So, the typical Linux file system follows a hierarchical directory structure. Let's see an overview of the basic directory structure. First is the root directory. It is represented as a single forward slash. The root directory is the top level directory in the Linux file system. Everything in the file system is organized under this directory. The root directory contains all other directories and files. Next, /bin, that is binary. This directory contains essential binary executables and commands required for system recovery and maintenance. It includes commands such as ls, cp, copy, mv, move, and cat. Next, /boot. This directory holds the files necessary for the initial stages of the boot process, including the Linux kernel and bootloader configuration files. Next, /dev, that is device. This directory contains device files that represent various hardware devices and peripheral components. These files allow interaction with hardware devices such as hard drives, printers, and input devices. Next, /etc, that is etc. This directory stores system-wide configuration files and scripts. It includes configuration files for the operating system, user accounts, network settings, and more. Next, /home. User home directories are typically located under the /home directory. Each user has a subdirectory within /home to store their personal files and settings. Next, /lib, that is library. This directory contains essential shared libraries and modules required for the operating system programs and dynamic linked executables. Next, /media. This directory is used for temporarily mounting removable media such as USB drives and external hard disks. Next is /mnt, that is mount. Similar to /media, the /mnt directory is used for manually mounting temporary file systems. Next, /opt, that is optional. This is often used to store optional software packages and applications that are not part of the core system. These packages are typically installed by the user or system administrators. Next, /proc or process. This directory provides a virtual file system that exposes information about running processes and kernel parameters in a structured format. It's a crucial interface for system monitoring and management. Next, /root. The home directory for the root user or the super user is located at /root. This is the super user's equivalent of the /home directory for regular users. Next, /sbin, that is system binary. Similar to /bin, the /sbin directory contains essential system binary executables, but these are typically used for system administration tasks and are not intended for regular user use. Next, /srv service. This is intended to store data files for various services or applications provided by the system. It helps keep data separate from executable files. Next, /sys is system. This is used to interact with the kernel, exposing various kernel parameters and settings in a structured manner. Next, /tmp temporary. This is used for temporary file storage. Files in this directory are typically deleted upon system reboot. Next, /usr, that is user system resources. This contains user related system resources including user commands, libraries and documentation. It is typically read only. Next, /var variable. This directory holds variable data such as system log files, mail spools and temporary files that may persist between reboots. So this is a high-level overview of the basic directory structure in a typical Linux file system. The structure provides organization and separation of system and user files, making it easier to manage and maintain the system. Different Linux distributions may have additional directories or variations, but the core structure remains relatively consistent. Let's go to the next question. How do you find information about a command in Linux, including its usage and options? There are various built-in tools and commands you can use. Like for example, you can use the man command. The most comprehensive way to access command documentation is by using the man command followed by the command name. For example, to view the manual of the ls command, you can use man ls. The man command provides detailed information about the command, including its usage, options, descriptions, and often examples. Next, many Linux commands support a --help option. This option typically provides a concise summary of the command's usage and available options. For example, to get the information about the ls command, you can use the help option as ls space --help. Next, online documentation. So some manual pages. So you can access online manual pages for most Linux commands on various websites. For example, the Ubuntu man page repository provides a user-friendly web interface to browse command manuals. The website is manpages.ubuntu.com. You can search for a command by name and you'll find the online manual page with detailed information. Next, some commands like info provide documentation in a different format compared to man pages. You can access this information using the info command followed by the command name. For example, to access the info documentation of the ls command, you can use info space ls. Next, in many Linux shells, you can use tab completion to explore available command options. After typing the command name, press tab key to see a list of available options and arguments. This method is particularly useful for discovering available options without having to refer to external documentations. Next, online search engines. Whenever you are in doubt, you can use search engines to find information about a specific command. Simply enter the command name along with Linux or Unix in the search query. You'll often find online resources, forum discussions, and tutorials that provide insights into the command's usage. Remember that the availability and format of documentation may vary slightly between different Linux distributions. Using the man command and the dash dash help option are usually the quickest and most reliable ways to access information about a command, while online documentation can provide additional context and examples. Let's go to the next question. Explain the difference between a soft link and a hard link in Linux. Soft link, also called symbolic links, and hard links are two different types of links used in Linux and Unix like operating systems to create references to files or directories. They serve different purposes and have distinct characteristics. First, let's talk about the soft link. A soft link is a separate file that contains a reference to the target file or directory. It essentially acts as a pointer to the target. Soft links can span file systems, meaning they can reference files or directories located on different storage devices or partitions. If the target file or directory is deleted or moved, the soft link becomes a dangling link, and this points to a non-existent target. Soft links can reference directories, files, or even non-existent targets. Soft links are created using the ln command with the -s symbolic option, like say ln-s target and then link name. Soft links are identifiable by the L at the beginning of their permissions when viewed with the ls-l command. Now let's talk about hard link. A hard link is a reference to the inode. Inodes are data structures used by the file system to store file metadata and data locations. Hard links are limited to referencing files, that is, not directories, and must be on the same file system, that is partition. If the original file is deleted, the hard link continues to exist because it references the same inode. The data is only marked as free when the last hard link to the inode is removed. Hard links essentially create multiple directory entries pointing to the same data on disk. All hard links are equivalent. There is no concept of a main file and linked files. Hard links are created using the same command ln but without any special options. Like suppose say if you want to create hard link, you just say ln target and link name. Hard links are identified by having the same inode number as the target file when viewed with the ls-i command. So in summary, the main difference between soft links and hard links are that soft links are separate files that can span file systems and are not dependent on the existence of the target, while hard links reference the same inode on the same file system and depend on the target's existence. Hard links are commonly used for creating multiple references to the same file, while soft links are often used to create symbolic shortcuts or references to files and directories. Let's go to the next question. How do you change file permissions in Linux using the command line? So in Linux, you can change the file permissions using the chmod command in the command line. This command allows you to modify the read, write, and execute permissions for files and directories. Let's see how to use it. The basic syntax of this command is first chmod, and then the options, and then mode, and then file. Options, these are optional and allow you to specify additional settings. Mode, this specifies the new permissions you want to apply to the file. And then the file is the file or directory for which you want to change the permissions. So mode can be expressed as a combination of 3 digits or as a symbolic notation. First, we'll look at the 3-digit numeric. The 3 digits represent the permissions of the owner, group, and others. That is everyone else. Each digit is a sum of permission values. 4 for read, 2 for write, and 1 for execute. So if I write chmod 640 and the file name, this is setting read and write permissions for the owner because it is 4 and 2, and the first one is for the owner, and then 4, that is read only permission for the group, and then 0 means no permission for others. Now let's look at the symbolic notation. This allows you to use letters and symbols to set or modify permissions. The symbolic notation consists of 3 parts. First is the target. For example, U for user, G for group, O for others, A for all. And then there is operator. For example, plus means add permissions, minus is to remove permissions, is equal to is to set permissions. And the other one is permissions, that is R for read, W for write, and X for execute. So these are the 3 parts: target, operator, and permissions. Now let's look at an example. If you write chmod u plus X file name, then this is to add execute permissions to the owner. Now let's look at the options. So here we said there are options, right? Let's look at what options you can use. Dash capital R, or you can say dash dash recursive. If you use this option, it changes permissions recursively for all files and directories within a directory. Then you can use dash V or dash dash verbose. This is to display the changes made to the permissions. Next is dash C or dash dash changes. This is to report only when changes are made. Next is dash F or dash dash silent or dash dash quiet. This is to suppress most error messages. Now let's look at more examples. So if you say chmod u plus x, comma G plus X, then file. This is to add execute permissions for the owner and group on a file. Next, if you say chmod A minus W file, then this is to remove write permissions for all users, that is owner, groups, and others on a file. Next, if you say chmod hyphen capital R 755 and then directory. This is to recursively change permissions for all files and directories under a directory. Note that it is important to be cautious when changing permissions, especially on system files and directories, as incorrect permissions can affect the stability and security of your system. Always use the chmod command with care and consideration. Let's go to the next question. What is the purpose of the grep command and how would you use it to search for a specific string in a file? So grep command is a powerful text search tool in Linux and Unix-like operating systems. It is used to search for specific patterns, strings, or regular expressions within text files or the output of other commands. The basic syntax of grep command is grep options pattern and then file. Options, these are optional and allow you to specify search patterns or modify the output. Next is the pattern. This is the text or regular expression you want to search for. Next, this file is the file or files in which you want to search the pattern. You can specify multiple files for batch searching. So if you write grep search text file.txt, Then this is to search for a specific string, like for example, search text in a single file, that is file.txt. If you want to do it in multiple files, then you can write grep search text star dot txt. This is to search for a string in multiple files. For example, all the .txt files in a directory, you can use this wildcard character star. So by default, grep is case sensitive. For you to do a case insensitive search, you need to use the option -i. So it will be grep -i search text file.txt. This is going to search for search underscore text case insensitive in the file.txt. Next, to count the number of times a pattern appears in a file without displaying the matching lines, you can use -c. So if you say grep -c search text file.txt, it will tell you how many times this search text is present in file.txt. Next, grep supports regular expressions. For example, to search for lines that start with apple or like say banana, you can use or pipe operator in a regular expression, like say grep, and then you use this apple or banana within quotes file.txt. Next, if you want to perform a recursive search in a directory and its subdirectories, then use the -r or -R option. So you search grep -r search text and then the path to directory. So you said grep -r recursive, then you're searching for the search text in this directory. So you're giving the path of the directory. It will consider it subdirectory as well because of -r. Next, if you want to show line numbers in the output, then you use the -n command, same grep -n search text, then file.txt. The grep command is a versatile tool for searching and extracting information from text files. It's particularly useful for tasks such as log file analysis, text processing, and finding specific strings or patterns in large data sets. Next question. How do you compress and decompress files or directories in Linux using tar and gzip? So the combination of these tools allows you to create compressed archive files, often referred to as tarballs, and extract files from them. Let's see the basic commands for compression and decompression. First, let's talk about compression. So to compress, you can write tar -czvf compressed file dot tar dot gz and then file to compress. First, let's look at the options. C is to create a new archive. Z, use gzip to compress the archive. -v is verbose mode. It's optional but useful for seeing the progress. Then -f is to specify the output file. In this case, the output file is compressed file.tar.gz, and file to compress is the name of the file that you want to compress. So you write tar -czvf, then the output file name. Right now I'm writing it as compressed file.tar.gz and the file that you want to compress at the last. It's the same for directory as well. Tar -czvf compressed directory dot tar.gz and the directory to compress. Now let's look at how to decompress with tar and gz. So to decompress to the current directory, you're gonna write tar -xzvf compressed file dot tar dot gz. X is to extract files from the archive. But if you want to extract the contents of the archive to a specific directory, you can use the -C option followed by the directory path. So you will write the same tar -x gzip compressed file.tar.gz, and then you will use -C and then path to destination directory. So these commands allow you to create compressed archive files for efficient storage and transfer, then extract the original files when needed. The combination of tar and gzip is a common method for handling archives in Linux. Next question. Explain the ps command and how you would use it to list running processes on a Linux system. So the ps command is used to display information about the processes running on a Linux system. It provides valuable insights into the currently running processes, their status, resource utilization, and more. The ps command can be quite versatile with several options available to customize the output. Let's see some examples. So the basic syntax is ps options. Options, these are optional and allow you to specify what information you want to retrieve and how you want it to be displayed. To list all the processes running on the system, you can use the AUX options. So if you say ps AUX, it will display the list of all the processes that are running on the system. And if you want to list processes for a specific user, you can use the -u option followed by the username. For example, to list processes for the user John, you can use ps-u John. You can customize the output format using the -o option. Say, for example, to display the process ID, that is PID, command name, and memory usage RSS for all processes, you can use ps-eo PID, that is process ID, CMD, that is command name, and RSS, memory usage. This will allow you to create a custom output format by specifying the desired fields. To display parent and child processes in a tree-like format, you can use the option F. You can just say ps-af. This is useful for understanding process hierarchies and relationships. You can use option say -g and -s to list processes by process group or session ID. So if you write ps -g 1 2 3 4, then this will list the processes in process group 1 2 3 4. If you write ps -s 5 6 7 8, then it will list processes in session 5 6 7 8. And then you can use top command in combination with ps to monitor running processes continuously. The top command provides real-time updates on process information, including resource utilization. These are just a few examples of how you can use the ps command to list running processes on a Linux system. The options provided with ps allow you to customize the output to match your specific needs for process monitoring and analysis. The ps command is a valuable tool for system administrators and users to gain insights into the behavior of processes on a Linux system. Let's go to the next question. What is the purpose of /etc/password and /etc/shadow files in Linux, and how are user accounts managed? So in Linux, password and shadow files play crucial roles in user account management, but they serve different purposes. First, let's talk about etc password file. This is a system file that stores basic information about user accounts on a Linux system. Each line in this file represents a user account and contains information such as the username, user ID, that is UID, group ID, GID, user's full name, home directory, and the default shell. The etc password file is typically structured with 7 colon-separated fields per line, each containing user account information. Let's see an example. So it's username, colon password, colon UID, colon GID, colon full name, colon home directory, colon shell. So this will be the format. The user account information is primarily managed by system administrators or through user account management commands. Some of the commonly used commands are user add, used to add new user accounts, user del, used to delete user accounts, user mod, used to modify user account attributes, then password passwd, used to change a user's password. Now let's talk about etc shadow file. This is responsible for securely storing user password information. Unlike the older etc password file, which used to store password hashes, the etc shadow file is more secure because it contains password hashes and other account security information. It is only accessible by the root user. The etc shadow file contains multiple colon separated fields, including the username, password hash, password related information such as password expiration, and more. User account passwords and password related attributes are primarily managed using the etc shadow file. Let's see some of the commonly used commands for password management and user attributes. First is passwd, used to change a user's password and related settings. Next, chage, used to set password aging information such as password expiration and inactivity periods. Then user mod, used to modify user attributes including password related settings. Password hashes stored in etc shadow file are securely hashed using algorithms like SHA-512, making it difficult to retrieve the original password. Now let's see how user accounts are typically managed. First is creating a user account. To create a new user account, the user add command is used to add the user's information to the etc password file and create the user's home directory. The password is usually set separately using the password command, which updates the etc shadow file. Once this is done, next, changing user account information. The user mod command is used to modify user account information stored in the etc password file, while the password command is used to change passwords and related settings which are stored in the etc shadow file. And then deleting the user account. The user del command is used to delete a user account, which involves removing the user's entry from the etc password and etc shadow files, as well as any related files and directories. The separation of user account information in etc password and sensitive password information in etc shadow files enhances the security of user accounts on a Linux system, as only the root user has access to the shadow file. This helps protect user passwords from unauthorized access. Let's go to the next question. Describe the role of the sudo command in Linux and how would you grant a user sudo privileges? The sudo command in Linux is a powerful utility that allows authorized users to execute commands with the privileges of another user, typically the root user. It provides a means of performing administrative tasks or other privileged operations without having to log in as the root user. This enhances system security by limiting the scope of potential damage that can be caused by mistakes or malicious actions. Let's see some of the key roles and features of the sudo command. First one is delegating privileges. Sudo allows system administrators to delegate specific privileges to users or groups of users. This delegation can be fine-tuned to control exactly which commands a user can run with elevated privileges. Next, logging and auditing. Sudo logs all commands executed with elevated privileges. This auditing capability provides an audit trail of who did what, enhancing system security and accountability. Next, password authentication. By default, sudo requires users to enter their own passwords when executing commands with elevated privileges. This ensures that only authorized users can use sudo. Now let's see how to grant a user sudo privileges in Linux. First is that edit the sudoers file. The sudoers file is located at etc/sudoers. This should be edited to grant sudo privileges to the user. It's important to use the vi sudo command for editing this file as it provides syntax checking and prevents mistakes that could lock you out of the system. Open the sudoers file with vi sudo using a command like sudo vi sudo. And then to grant a user sudo privileges, add an entry to the sudoers file. The entry format is something like username all is equal to all colon all space all. You need to replace username with the name of the user you want to grant sudo privileges, like for example John. All is equal to all colon all part of the entry allows the user to run commands as any user and any group on any host. The final all specifies that the user can run any command with sudo. Once you add this entry, the next step is to save the changes and exit the text editor used by the vi sudo command. This will update the sudoers file. Next is to test if the sudo privileges are working fine. So you can ask the user to execute commands with elevated privileges. For example, the user can run a command with sudo using the syntax sudo space command to execute. The user will then be prompted to enter their own password to confirm their identity. So by following these steps, you can grant sudo privileges to a user, allowing them to perform administrative tasks or other actions that require elevated privileges on a Linux system. Be cautious when granting sudo access as it provides powerful capabilities and unnecessary or incorrect commands can have significant consequences. Always grant sudo access only to trusted users and limit the privileges they receive to the minimum required for their tasks. Let's go to the next question. How do you schedule a task to run at a specific time or interval using cron? So in Linux and Unix like operating systems, you can use the cron service to schedule tasks to run at specific times or interval. The cron service is controlled by the cron daemon and it allows you to automate repetitive tasks such as running scripts, backups, or system maintenance. Now let's see how to schedule a task using cron. First, edit the user's cron tab. Each user can have their own set of scheduled tasks. To edit the current user's cron configuration, you can use the command cron tab -e. The command opens the user's cron configuration file for editing. Next, we need to specify the schedule. In the cron configuration file, you will define the schedule when the task should run. The schedule format consists of 5 fields: wildcard and then your command to run, and then the day of the week 0 to 6. 0 is Sunday, so 1 becomes Monday, Tuesday, 2 goes on. Next is the month 1 to 12. Next is the day of the month 1 to 31, and then the hour 0 to 23, and then the minutes 0 to 59. Wildcard, this is a wildcard, meaning any value is acceptable. You can use specific values or ranges for each field. For example, to run a script every day at 3:30 p.m., the schedule would be 30, that is the minute, and then 15, that is 3 p.m. And then because it is every day, next 3 options will be star, and then you can provide your command to run. Once you have defined the schedule, add the command that you want to run at the specified times or intervals. Make sure to provide the full path to the script or command if it's not in the system's default search path. Next, you save the changes and exit the text editor. The cron service will automatically update the scheduled tasks. If you want to view the list of your scheduled tasks, you can use the command cron tab -l. If you need to edit or remove a scheduled task, you can use the cron tab -e command again, and it will open the editor with your existing tasks. And if you want to create system-wide cron jobs, regardless of the user logged in, you can edit the system-wide cron configuration files in /etc/cron.d. These files follow the same schedule and command format. For example, to edit the system-wide cron jobs, you can use sudo nano /etc/cron.d/my cron job. Make sure to specify the user whose permissions you want the job to run with. So that's how you schedule a task. The cron service will automatically execute the specified command at the designated times. Remember to test your cron jobs and ensure that the commands and paths are correct to avoid issues with your scheduled tasks. So that's it for today, guys. I hope this helped you learn a little bit about Linux. There are more parts to this interview, particularly Linux. I will add them in the description box as and when I upload the new ones. Please don't forget to like, subscribe, and share our videos. That helps us a lot. I will see you in the next video. Until then, take care of yourselves. Bye bye.